All right, this video is for the lesson 5.6 homework. So vocab first. What is the name of a set of two or more inequalities and two or more variables? So we've been doing systems of equations. These next 2 days we're going to be doing systems of inequalities. Actually, let's switch colors here. All right, and then number 2, what is the name of the set of all points whose coordinates satisfy the constraints of a problem? This is called the feasible. Ooh, never mind, that one's even worse. Feasible, try again, region. All right, so today, our inequalities are in slope-intercept form. Easiest way to graph, okay? The biggest difference between when we did this for equations and graphed is we've got inequalities. So remember, our lines are different. So if they use this sign or this sign, is it a solid or dashed line? It's a dashed line, okay? So if it's these signs, it's a solid line, okay? And then greater than or less than. So if it's less than or equal to, you find the y-intercept and you shade below that point, okay? If it's greater than or equal to, find the y-intercept where it crosses the y and you shade everything above that point. All right, so number 3, our first one here is 1/2 x plus 2. And then we know it's going to be a dashed line. So we start at the 2, our y-intercept. That's a point. So on the y-axis, remember this one's the y, we put a point at 2. And then the slope is 3 over 2. 3 over 2 means I go up 3 over 2. So from this point, I count up 1, 2, 3. And then over 2. And that's it. Okay? Again, dashed line. Okay? Doesn't have to be pretty, just has to work. And then y is less than. So when I shade this one, I'm trying to figure out the best way to shade this so y'all can see what I'm doing. You don't want to shade like super heavy dark, okay? So y is less than. So here's the y-intercept. That means I'm going to shade below. What I would do is just kind of lightly kind of mark it like that, because you're going to have to shade again when we do this next one, okay? You'll see the reasoning. All right, the next line. Y is greater than or equal to, so solid line. Negative x minus 3. All right, the number at the end, the minus 3. That's a dot. On the y-axis, I can put a dot at negative 3. All right, remember, in front of that x, there's an invisible 1. So my slope is negative 1. If it's just a whole number like that, stick it over 1. Make it a fraction. So if it's 2x, 2 over 1. 3x, 3 over 1. Negative 4x, negative 4 over 1, okay? Nice pretty numbers, just put over 1. So negative 1 means we go down 1 over 1. So from this point, down 1 over 1. And then a solid line. Okay. And then this one says y is greater than. So we would shade everything, where's my y-intercept, above this line. So from the purple line, I'd shade everything up here. Now your answer to this is where these two things cross, where the shading overlaps. So you can see where my shading overlaps because I did it in two different directions. It's this section. Because you're going to shade below this line and above this line. So you have to stay in between those two pieces. So I'm just going to do mine in a color here where y'all can see. And y'all can do the same thing. I've got colored pencils at the back. I would use colored pencils and not markers. The markers will bleed through. But for the ones we're working together, but you just want to make sure that that section's nice and dark and way darker than everything else. On the quiz tomorrow when we graph, remember all you have to do is just click where it overlaps, okay? And it'll shade it in for you. All right, let's do number 5 now. So we just do the same thing. Take the first one, y is greater than, so that's a dashed line, negative x plus 2. So plus 2 means there's a dot at positive 2. All right, then we've got 4/3 x. So 4/3 means we go up 4 over 3. So up 1, 2, 3, 4 over 1, 2, 3. So I just put it at the very top. The other thing you could do 1, 2, 3, 4, 1, 2. I don't want to confuse, although there's going to be a point at negative 3, negative 2 as well. You can also do the menu 3-2 on this. Except you're going to change the signs to equals because your calculator can't do inequalities. Now this doesn't give you the entire answer, but it will help you graph. So negative 1/3 x minus 3. And what I mean by that is this point that it gives you, the negative 3, negative 2, that's a guaranteed point. You know your two lines are going to cross there. So it just kind of gives you another point that you can graph. Oh, yeah, there's colored pencils in there and then in that light green basket up there if y'all just, however you want to grab. All right, and then we said dashed line. Okay, so there's that one. And then my other line, y is less than or equal to, so solid line, negative 1/3 x minus 3. So minus 3 means there's a point here. But if you remember from the calculator, negative 3, negative 2, this was also a point. So technically, I don't even need to do the slope. I can if I want, but I don't have to. Because I know that's a guaranteed point. I know that's where they cross. So, if I can get my ruler in here. Alright, that's a solid line. Oop, I didn't shade. I should have shaded as I was going, so I remembered which line was which. So this line was my top line. Y is greater than. So from the y-intercept, we're going to shade up. So all of this. My purple line, y is less than. So from the y-intercept down. So the overlap is just that tiny little piece right in here. And so sometimes these questions will ask you, is the point, let me pick one that's not, 3, 2, this point here, is it part of the solution? If it's not in that shaded area, it's not part of the solution. Okay? Another one might say, is the point -5, -3, which is right here. Is that point in the solution? Yeah, it's in the shaded spots. Sometimes they say a point that's like on the solid line. If the point falls on the solid line, it's a solution. If a point falls on a dashed line, it's not a solution. Okay, so in the shading or on a solid line is the only way it's a solution. All right, let's flip it over. So I'm going to leave you these two. All right, negative 2x minus 7, 11x plus 6. So what I'm going to do first on this one, I'm going to do the menu 3-2. Remember, y equals. Don't put the inequality signs in these. Because all we're looking for is the point where they cross. All right, so they're going to cross at -1, -1, -5. So that is guaranteed to be a point on both lines. So -1, -5 is right there. Guaranteed point on both lines. Oh, that's wrong.
Yeah,
That's wrong. That's +1. So not that one. Don't put it there. So -1, -5. Then all you have to do is look at the y-intercept. So my first line is a -7. So on the y-axis, I go down to -7, and that's my other point. Now, y is greater than or equal to, so that is a solid line. Okay. And then y is greater than, which means I'm going to shade above. Find the y-intercept and shade above it. So that's all of this. Okay, then I do the other line, 11x plus 6. The plus 6 means there's going to be a point on the y-axis at 6. And then that pink dot that I have there, that's my guaranteed point. Both lines are going to go through that. Solid line. And then y is greater than this one, so above. That doesn't look right for some reason. It is. Above this line. Now, here is this, see this purple line here? It can't go past that. Does that make sense? So above this purple line, it's real shallow, would be all of this. But that's why I say go to the y-intercept. If it's greater than, color above the y-intercept, draw an arrow going up. And that way you kind of know which side of the line to be on. And so the intersection here is this. How do we feel about this? Are we okay? What's tripping you up, Zach? Okay, well, if I ask you if you're okay, and you tell me no, you're going to need to tell me why so I can help you. All right, last I'm going to do with you, because this one's kind of got a special one in there. All right, y is greater than 6x plus x. Y is less than or equal to -6. All right. I know. Hang on. So we're still going to do the menu 3-2. And so that bottom one would just be y equals 6. So my guaranteed point is 0,6. So that means there's going to be a point 0, 6. Okay. 6x plus 6. Plus 6 means that's where the point is. So that one doesn't really help me here. So something else I can do. Take just the equation, the 6x plus 6, and I can go into the graph. I don't want to change it. I want to pretend like it's y equals and just do 6x plus 6. And then I can pull up the table. Okay? So there's a point at 1, 12. 1, 12. Well, that's not on there. So let me go the other direction. 0, 6, we've got that one. -1, 0. That's that point there. -2, -6. -2, -6. I can pull some points off that table. So it's not going to graph it like an inequality, but it will graph the ordered pairs that make the line. And so this one's a dashed line. Does everybody see why it's a dashed line? Because there's no line underneath the inequality sign. And then y is greater than. So here's the y-intercept. So shade this way, which means everything on that side of the line is greater than. I know it doesn't seem that way, but it is. The y's are getting greater that direction. All right, so we can use that pink point again. Ooh. I see what I did wrong. Do y'all see what I did wrong? Menu 3, 2. 6x plus 6. It's y equals negative 6. I don't know that I did that this time. So negative 2, negative 6. That should have been my guaranteed point. This point here. Sorry about that. All right. Y is less than or equal to negative 6. If there is just a number after the y, it's a horizontal line that's going through that y value. It's solid. So at negative 6 on the y-axis, you're just going to draw a solid line. Now, y is less than. So do you think you would shade above that pink line or below that pink line if y is less than? So again, here's the y-intercept. Less than is below, so you can use that same technique. And then where it's double shaded, that's your solution.